Hi, Dr. Rafiq. It is my pleasure today to interview you. Just for background information, Dr. Rafiq is a professor at the University of Alberta Department of Mechanical Engineering. He's also the founder and director at the Smart Lab at U of A Engineering. I'm happy to chat with him today about his passions and how he wants to carry his work and research. So first off, why don't you tell us a bit about what are your inspirations to start your research?
Thanks, Jamie, for interviewing me today. I think when it comes to the general research area, I always like to research which has impact on the society. That could be system design and development, which can impact the society, or it could be something to protect the environment, to protect our future generation, to educate our future generation. So some of these areas I am quite interested in. So whatever the research topic is, but it should have an impact on the society directly. That's kind of the general goal and theme of the research lab I'm currently leading. When it comes to plastic recycling in general, I'm quite passionate about this from many angles. One, that it has a societal impact. It is protecting the environment for the future, not only for us, but also for the animals, for plants, for fish. All these things, all the edible thing which we eat, all these can be contaminated. So in one way or another way, it is directly linked to our society and to us as humans. So it is very important to think about plastic in that perspective, and then look into what are the different types of research directions which we can look into. Plastic as a whole is very complex system. So it comes from materials, it comes from the climate side, it comes from technological development, different types of products, and how do you actually use them, manufacture them, recycle them. And since our lab is purely focused on manufacturing systems, so we target how do we actually manufacture and remanufacture these plastics.
Yeah, plastics is definitely becoming a big issue now on the global scale. So how did you first start this research, and what was the first thing that you did when you started?
So, I mean, well, plastics was always in my mind. We were doing a lot of plastic and polymers 3D printing from different research directions, and we were looking into multi-material 3D printing, and there was always this issue coming up to our mind and from our partners, that whatever plastic we manufacture today, it has to be in such a way that tomorrow we can actually look into design for recyclability, that how do we actually recycle that. And that's one of the big challenge, because sometimes you mix plastic with wood, sometimes you mix plastics with metal, and then when you want to recycle them, there is no way to recycle them, or it's very complicated or very expensive to recycle those kind of products. So in terms of the designing different types of products, in terms of 3D printing with different types of polymers, we were always looking into how do we actually design something which can actually recycle better in the future. So we call it design for recyclability or design for environment. Those were some of the things which were quite important from the beginning, since I started research in 3D printing in manufacturing areas. But then particularly looking into how do we actually take this existing plastic and recycle them came after COVID. When the COVID started, we actually were looking into different types of product, and we developed this personal protective respirator for frontline workers, for medical doctors and nurses. That technology was quite important because it was directly a societal impact for our doctors, and it was quite important. The material which we were using at that time was plastic. It was different types of PLAs or ABS or silicon we were looking into. So one of the important thing were there was that how do you actually clean these kind of products? How do you actually recycle those plastics? That was always an important issue we were looking into. But then there was a time when we were actually manufacturing those personal protective respirators. We ran out of materials, and you know that with disruption, COVID, there was always a huge issue that there was a 2 to 3 weeks of waiting time for materials to be received. And I'm talking about the virgin material for PLA or ABS or anything. So it was taking a lot of time for us to take that. So we sat together with my team and I asked them, okay, we have actually prototyped some concepts and products already. Can we just take that material, that's a PLA, again, we can shred it and we can recycle it again. And then we started looking into the recyclability aspects because there was no material available. While we were waiting 2 to 3 weeks, we started looking into our own material, which we had in our lab. And then we start slowly and gradually looking into the issues which we encountered for recyclability. And we found out that it's a huge thing in its own, because currently there is not a lot of science behind how many times you can recycle a particular plastic coming out of a particular functionality. And then once you have that, how do you actually enhance that kind of life within a particular plastic? Either you add additives, or you mix different types of plastics together, or you manufacture it in such a way that it is faster to be recycled or reused in another time. So that was kind of the concept we were looking into, and that's how we jumped into plastic recycling. And we found out that many organizations, very not-for-profit organization, they were super interested in recyclability, and we looked into those quite seriously.
So it was great that you were talking about there's not really a standard on the current system about how many times a particular plastic can be recycled. And my next question is about that. Is about what are your thoughts on the current numerical system on recycling plastic?
So currently, I mean, there are many existing solutions, technologies available across the world looking into recyclability of plastics. But plastic is a very complex process, from taking in a functional product to shredding and then kind of recycling it. It's not that simple, depending on whatever the product is. Maybe for certain products, if it's made out of one plastic material, it's very easy to do it. But for others, it might be very complicated. So there are some solutions available, but they are very monotonous in a sense that whatever plastic you have, you just take that, you shred that, and then you can actually use to create filament out of that, and then you use existing 3D printing technologies. The research which we are doing, on the other hand, is a large format 3D printing technology, where we look into taking any plastic and then kind of either shredding it or creating pellets out of it or creating filament out of it, depending on whatever you are interested in. You can also mix it with virgin material, and then you can use that with our hybrid eco 3D printing solution, which can give you a much better surface finish as well. And it's a very smart and hybrid technology which can actually be used to kind of take any plastic and can be recycled with that. Currently, we still have some challenges. We have not implemented it on all the different types of materials. Especially for mixed material, it is quite challenging because we can do it. We can 3D print with mixed material as well. But the issue is that when you use mixed material, then you will be burning one material and then kind of printing or melting another material depending on their melting temperature. So if the melting temperature is very close, we can do it. But if it's there is a big difference between the melting temperature, then that creates some environmental issues, especially because you will be burning some materials. So that's why we don't want to provide a solution, because we are protecting the environment. So we have to look into how do we actually create a solution which is universal. So that's why, like, one of the pre-requirement of existing technology, and especially this one, would be to look into how do we actually take this material and then kind of remove take this material and then kind of remove any other material out of it. So you have an only single material, and then you use that material to 3D print with the technology.
Welcome to Smart Lab. Here, when it comes to plastic recycling, we are recycling any kind of plastic. The idea is to take any plastic used in household items or any industry. We take that plastic, we shred it first, we create some flakes. For example, this is one of the system which we are using. Here we put the plastic there, we shred the plastic, and we get some flakes similar to this one. These flakes are then used to create filaments, either with a machine like that. We create these 3D printing filaments, or we can use directly these flakes into creating pallets, or use it directly in our machine and system. So that's kind of like a general idea of the recycling. The main question which we are answering over here is that how many times a particular plastic you can recycle, so we can extend the life of particular plastics, and then kind of look into the usability aspects and other issues as well related to that. So our lab is equipped with most of these recycling equipments, and we have the capability to kind of recycle any plastic today. So we have some of these parts are commercially available, so we can take from the plastic to filaments and flakes. We can actually develop those with the commercial systems, but we have created our own solution, which is our eco printer. That printer is used to kind of 3D print with any of these recycled plastics. So maybe you can come over on this side. So this is the system where we recycle plastic. So the idea is to put the recycled plastic into a nozzle system, and that nozzle on this side comes over here, and that melt the plastic and create whatever shapes you're interested in.
Okay.
And it could be a simple product like these, or a bigger product like this, or anything else which you want to create. So the system currently is able to print 1 meter cube of an area, and we can therefore create bigger parts for any application we want. Currently, we are able to print one material at a time, but we are also investigating of mixing different types of material and seeing how we can impact those in the future. One of the main aspects related to the environment is that we are protecting the environment by recycling plastics, but also it is also important to see that when we are recycling an existing plastic, is there any impact on the environment. So we are actually using different types of sensors to detect different types of TVOCs, or also looking into kind of dioxin around that. So we currently we have tested these systems, and we can say for 100% guarantee that there is no dioxins, or there is no TVOCs generated which are above the limit of whatever is dangerous for the human health.
So the eco printers that you talk about, is this the machines that you showed me in the lab as well? I think when you gave me the lab tour, you talked about this as well, right?
Yes, yeah. So it's the same machine.
Okay. So you talked about the current system, and you talked about your eco printer machine. And those are great. I think those have great potentials to be more widely applied. The next question is, what are your thoughts on microplastics? Do you think they are a big threat? Do you think there's any good ways to address those?
Yes. So I think microplastic is one of the biggest issue for us and for our future generation, and also fish, animals, anything on the planet. I think it's very important to look into how do we actually prevent it even going there. Once we have it out there, it's pretty hard to look into how we can actually get it back from the environment. There are some researchers looking into those, but I think as a researcher, as an engineer, my goal is more into not even going there, right? So I think the biggest impact which we can do on our society and especially the future generation would be to look into those microplastic, not even going into the environment, right? So, and that's why we need to tackle this plastic issue more seriously, looking into how do we actually handle plastic, how do we actually manufacture products, and how do we actually create policies around that, and then probably all the different products, we need to create different types of systems, technologies. We need to invest in these technologies which can take any existing plastic and take that and recycle that and give it a new life. I think those would be very, very important, so that the product doesn't go to the environment directly, but it creates a new life for that product. So I think microplastic in general is a very important issue. But for me, when I look into it from the perspective of an engineer or engineer eye, it is very important for me to look into the products and the future products and how do we actually handle that. There are lots of scientists, they will look into how to protect the environment when the plastics are already there. But I think the existing solution into existing plastic in the environment, in our current household items are a lot. So we need to take serious actions to kind of prevent them from becoming the microplastic in the future.
And so following that, my next question I want to ask you, what do you think is the most important message to the public about production and consumption of plastics?
I think the very important message I would want to give would be that plastic is not a problem of a government. It's not a problem of an engineer, or it's not a problem of a doctor or anybody else. It is a problem of everybody. We'll need to take serious action in the future to look into these plastic. Even anybody who's not even related to education or research or anything technical and has no background education should also be looking into how to use a responsible plastic, use in their household and different things which we are actually looking into in our lives. So it's super important for us to think about the plastic problem is our problem. That is the very first thing we need to think about. And once we know that, then we need to find ways on how do we reduce those plastic. If it is within our capacity to educate people, we should educate people. If it is within our capacity to look into plastic more seriously from the perspective of not using a lot of plastic in our house. For example, I'm going for shopping. I can just take a reusable bag to not use plastic anymore. I can actually take products or parts or buy things which are not plastic related. Those are the things which we can easily do in our capacity, and we can actually avoid using plastic. And especially single-use plastic. If it's we should also encourage that if there are some initiatives of reused plastic in some ways or another way, if there are companies who are reusing plastics and creating new way and new life of products, we should be definitely buying those so that we can encourage them, so that we can actually create those kind of reusability in our plastics in the future.
Yes, I agree. I think that's a very important aspect. It's not just one particular group. It's not just the academics or not just the government. It's everybody needs to work together. And so, I know you and your lab, you have already created some progress. You've offered some solutions to the issues about plastic. My next question is, how do you wish to move forward with your research? And what do you see as a challenge that you face in moving forward with this area of research?
So, I mean, we definitely want to move forward with developing new technologies for plastic recycling. We want to create different types of sensors which can quickly tell us what kind of plastic it is or what kind of combination it is. We are interested in creating different types of sorting stations, using robots to kind of sort different types of plastic. We are also interested in looking into computer vision and AI for those kind of detection, quickly early detection, and also kind of looking into kind of ocean related research, that how do we actually create different types of technologies which can go and collect and map those plastics across the ocean. But we are also interested in working with different types of companies across Alberta, especially, who are interested in recycling some of their plastic. We encourage them that they can send us their products and we can actually reuse and try to reuse their plastics and kind of work with them. We definitely need more people around those areas, so we can train different types of people who are specialists in plastic, who know and understand plastic and will work with us to encourage these companies to hire them so that they can actually in the future be used for those kind of sustainability issues in the future. And we are more than happy to work and collaborate with them. If there's any seminars, workshops, or anybody is interested in plastic recycling, we are more than happy to provide those opportunities as well.
Interesting. So is there a specific aspect that is very challenging to you at this moment?
Definitely, there are many challenges across this. Plastic is a complex system, so there is the science part which we have, and we know that it's quite challenging. We have people, we have other expertise. We are not the experts in every field, so we rely on other expertise, collaborators, and people and expert scientists who work and help us in those. One of the biggest challenges is definitely funding. We are looking for further fundings around those so we can actually enhance those kind of technologies. But then also, if there is any interest from other people and companies, they want to give us their plastic, which we can actually use, and they can adopt those technologies. So I think the biggest challenge would be that industries coming forward and adopting our technology would be something which we would be very interested in.
Okay, so I have one question left. So my last question here is, if you could please describe REACT's research partnership with the University of Alberta and the Department of Mechanical Engineering.
Okay. So REACT is our very interesting partner and very valuable partner. We have been looking into plastic from the environmental perspective for the last couple of years. The main idea was to look into the safety part of how do we actually recycle plastic, and then create certain education materials like videos, and then also kind of understand more the safety part of how we can actually look into the plastic, and when we are recycling, is this part safe or not. For this, we are looking into kind of creating or looking into different types of TVOCs and also dioxins, which can be generated if we are recycling plastic, or most importantly, they can be generated when we're burning plastics. So we want to understand that there is no such thing generated when we are actually recycling plastic using our large format 3D printer. So we have been looking into that from different perspectives. We have a TVOC sensors, which we are using at different levels, and we are creating some videos with REACT around that. We are looking into this TVOC measurement from outside, then inside on the machine, and also in the environment. We use this kind of measurement to see that we are not generating any organic oxides or volatile oxides, which can actually be harmful for humans. So we want to predict those and detect those when we are recycling plastic, and we have been looking into that. And then also we are quite interested in looking into dioxin in general, that are we generating any dioxin. It's very complicated process because there are very few solutions available, very expensive solutions available to measure dioxins. And so we are actually looking into how we can actually do that. There are a couple of ways to do that. One of the particular ways which we are interested in looking into is kind of creating fumes out of the machines, fumes or just the air coming off the machine. Currently, we don't have any fumes, but just extracting the air into a filter and then using that filter to test it in other labs, which we would be interested in looking into, that how we can actually test those for particular dioxin, that if it exists when we are recycling it with our own machine or not. So that's one way to look into it. There is another way that we can actually take some air coming out of that machine when we are printing materials, and then use that solids and then pass some laser technologies. Based on those laser technology, we kind of detect different types of dioxins around that. So that's also a longer term research we are looking into. We have not identified any best solution yet, because those all of these solutions are very expensive. But the idea is it's a longer term partnership with React. We are looking into how do we generate certain research or certain technologies or certain comfort with our existing technology, so that we know that, okay, this technology is safe. And then we actually prove that with certain videos or certain results in research. So we can actually show this product to the market, and we say that the plastic recycling is safe. So our goal in general between our team and React is the same. We are protecting the environment. We're looking into that from different perspectives. React is more looking into the education side of people, and then also looking into the environment protection and safety. And we are more into their technology development around that.
I would like to thank your time today, Dr. Rafiq. I appreciate you taking this time, despite being in a different part of the world right now. But I still want to thank you for taking this time to do this on Zoom with me. I wish you all the best in your future research, and I hope to see your solution and your technology being applied wider very soon in the future.
Okay.
Yeah, thank you.
Thank you. Thank you so much, Jamie, for your time. Have a good day.
Change will make for sunny days. Yeah, we'll live on in other ways.